we can use the idea of torque to help us do work. This is accomplished by taking the part of the definition of forces and torque that refer to distance. As its most basic, a machine is something that makes it easier to do work by reducing the amount of force needed to be put into the system. The mechanical advantage of a machine is simply the ratio of the amount of force coming out of the system divided by the amount of force that was put into the system. The higher the mechanical advantage, the more your machine is reducing the amount of work. The simplest type of simple machine is a lever. A crowbar is a good example of a lever and is probably something you have some experience with. Think about that nail there that we are trying to pull out of a piece of wood. Grab a hold of that sucker and pull. You can't move it, can you? This is where the lever comes in. If you attach one end of the lever to the nail, you can apply a force through the lever. The nail becomes a pivot point and the lever increases the distance through which you apply the force. The further away from the pivot point, the less force you have to apply. So let's define a few terms here. First, we look at the force that you are applying to the lever. This is called the input force. The perpendicular lever arm is the distance from the fulcrum to where the force is being applied. The output force is the force that actually gets applied to the nail. This is equal and opposite to the normal force that is acting on the nail. Then we have our output distance, that is the distance from the nail to wherever the lever is actually pivoting. As you can tell, this distance is much shorter than the input distance. It is these differences in distances that allow us to create a useful expression for mechanical advantage. The normal force is actually what is keeping the nail in place, so until the nail begins moving, the normal force is equal to the input force. This results in a net torque of 0 and allows us to write this in terms of torque. So the input force times the input arm is equal to the output force times the output arm. This relationship is that of mechanical advantage. A pulley is another type of simple machine. It is a device that loops a rope around a rotating disc. Now to begin with, we are going to assume a few things here. First, the rope has no mass, and it does not stretch. We also want to assume that the pulley and rope system is frictionless. So no energy is lost when the rope moves through the pulley. Otherwise, we are going to have to change our calculations, and we don't want to do that just yet. So on our side of the pulley, we have an object with a mass of big M. The force that it is applying to the rope is its weight, so mass times G. Another object is applying a different force to the other side of the pulley, also in the form of weight. The weights cause a tension acting upwards in the rope on either side of the pulley. Since we are not allowing elasticity in our rope, the two tensions must be equal to each other, and the net tension in the rope must be equal to 0. This means that the force applied on the left is equal to the force applied on the right. This is kind of interesting because that means for a single pulley system, you need to apply the same force to the rope that you would if you were to just pick up the object. Let's say we assign a weight of 100 newtons to our object. Then it would require 100 newtons of force to be applied in order to lift it. This gives us a mechanical advantage of 1. So in a single pulley system, we are not changing the amount of force required to lift the object, we are just changing the direction of the force as it's being applied. This might make it seem like it's easier to lift, but in reality we're still applying the same amount of force. Now a combination of pulleys can be used to multiply the force. In this example, the two pulleys result in the output tension force to be spread out among 2 ropes instead of 1. Essentially, there are 2 ropes now attached to the block, and each one applies the same force to the weight. If we take our 100 Newton block and try to lift it, the 2 ropes split the force and would only take 50 newtons of force to lift it. This gives us a mechanical advantage of 2. So what if we added a third pulley? Well, the 100 newtons of weight are now spread out over 3 supports. So that would give us a mechanical advantage of 3. And we can keep going on like this. For every support we add to our block, our mechanical advantage changes to reflect that. Suppose a wheelbarrow has a perpendicular lever arm of 7.50 centimeters, while the hands have a perpendicular level arm of 1.02 meters. What upward force must you exert to support the wheelbarrow and its load if their combined mass is 45 kilograms? We are wanting to find the upward force that we must exert to lift the entire mass of the wheelbarrow. Since we are looking for the upward force, we are actually looking for the force that we are applying, and that must be the force that we have input into the system. So we can rearrange our mechanical advantage equation to solve for the input force. We were given the input arm, which is the perpendicular lever arm that we are lifting, and we were given the output arm, which is the perpendicular lever arm that lifts the wheelbarrow. We are given the total mass of the system, which we can then use to determine the output force, which in this case would be equal to the weight of the system. All we have to do then is take our information that we need and solve it for the input force, and we find that it takes 32.4 newtons of force to lift the wheelbarrow with 441 newtons of weight. If you compare the amount of force that you put into lifting the wheelbarrow to the amount of force that is actually lifted, you can definitely see the advantage of adding on that lever arm.